Hello students, in this particular video we are going to learn about the concept of magnetic field of a solenoid and we have to learn to derive the expression of magnetic field inside a long straight solenoid. So first of all, what is a solenoid? So a solenoid means an insulated copper wire wound closely in the form of a helix. Suppose we have a frame, cylindrical frame, and onto this particular frame we are going to place some number of turns of a copper wire. Okay, it is going like this. So this is how we are placing the adjoining turns which are closely wound, and let us say we are passing the current in this particular coil in this direction. This arrow shows the direction of the current which are flowing in the adjoining turn. So this structure we call, this may be the core, this is called the black color one, this one we call as core, and the main objective of core is to support the coil, and there are some more objectives that we'll discuss at later point of time. They provide low reluctance path to the magnetic field which are produced by this current carrying this circular loops. So each turn are producing magnetic field and they are producing in the same direction, so they will be added vectorially and overall the total magnetic field will be there. So that magnetic field we are going to make the calculation in the second half or later part of this derivation of this particular topic. So how to decide? This is the coil, direction of current, core, everything is done. This is copper wire. So now first of all we need to mark the north and south polarity. This is acting like a magnet. So how to decide north and south pole, as well as we need to draw the magnetic field lines. So we need to grab this solenoid. This structure is basically solenoid. So we need to grab it in our hand, right hand, so that the fingers except thumb, all the fingers should point in the direction of the current. So to determine direction, what we need to do? Direction of magnetic field, or which one will be north and south pole. So we need to grab the solenoid, grasp the solenoid with the right hand, so that the fingers point along the direction of the current. Then the extended thumb will point, will indicate the face of north polarity. Face of north polarity, and opposite to that will become south pole. That is understood. So here if you are going to curl the fingers of your right hand, The remaining fingers will go from inner and it will come out from the top. So thumb will be pointing in this direction. So north will be this one and opposite to that will be south pole. So I am doing one thing. I am trying to draw the magnetic field. So here on this inner conductor, the current is entering, going into the plane of the paper, and here the current are coming out of the plane of the paper. So we are trying to represent the cross sectional view of the solenoid. So this is rectangular frame, and on the top and at the bottom, what is our observation? At these points, current is going into the plane of the paper, and here it is coming out of the plane of the paper. So this becoming south pole, this becoming north pole, and the direction of the magnetic field always used to be from south pole to north pole inside the magnet, and outside it is north to south, and this used to be a closed curve. So we can draw some of the magnetic field lines to understand the field lines surrounding to this. We can draw some more which may not be closed one. We can draw like this. Such figures you may observe in many books. So this is how inside the solenoid it goes from south to north, and outside it comes from north to south. Okay. So inside the solenoid, if you are going to observe, the magnetic field is uniform and it is constant or uniform everywhere, and nearly it is zero outside the solenoid. Okay, and these circular dots, they are representing direction of current which is perpendicular to the plane and coming out. Okay, perpendicular to plane of paper and coming out. And coming out, and dot we understood. Then cross is what? Perpendicular to plane of paper and going inward. Or into the plane of the paper. So this is very important. Definition of solenoid we can write in this particular topic. A solenoid means an insulated copper wire. A solenoid means an insulated means what? The adjoining turns, whatever we are drawing, they are electrically isolated. Electrically isolated means what? There is insulation placed between the adjacent turns of a coil. They are not directly connected to each other. That is the meaning. Okay. A solenoid means copper wire, an insulated copper wire wound closely in the form of helix. Closely in the form of helix. So This is how we have to understand the basic idea of solenoid. And whenever we say it is a long solenoid, it means that the length of the solenoid is very large as compared to its diameter. So long solenoid means what? The length of solenoid is very large as compared to its diameter. So the same figure we can redraw it, and we can have different direction of north and south pole. I am trying to draw at this point. You see, this is the iron core or frame on which we are going to place the coil. So this time we are placing the coil like this. So it is going from the top. Only sense of placing the coil on this particular core we are changing, and with that we are going to see how it is going to be affected. So now if you are passing current like this in the adjoining turns, it will finally come out. And now if we grasp this solenoid in our right hand and pointing the remaining finger except thumb in the direction of current, then outstretched thumb of our right hand is going to point in this particular direction, and that will become the north pole, and opposite to that will become south pole. So again, this is copper wire and this is the frame, iron core, soft iron core. Okay. So, and this arrow indicates the direction of current. Direction of current. So magnetic field will be from south to north forming closed loop, and this is how the magnetic field lines will be there. I am not drawing more than one loop because the figure will become unclear. Okay, I want to keep it clear. So inside it is south to north, outside it is north to south. Here also inside it is south to north and outside it is north to south. So sir, what is this? It is basically representing the magnetic field surrounding this particular closely wound current carrying coils that we are calling as solenoid. So inside it is south to north and outside it is north to south. Okay. So it is assumed that the magnetic field inside this solenoid is uniform everywhere and nearly zero outside this solenoid. And with this assumptions, we are going to proceed in our derivation in the next video. Thank you.